figured it out. Okay, I feel a little ridiculous. I just had to press it twice. So I don't know if you have this type of calculator. So you just press minus and then press where it says ln log, just press it twice and it gets immediately log. And then you can write 1 EE minus 3 close parentheses and then press equals or not, enter, sorry, and you have a 3, okay? So this type, I don't know if any of you have these types of calculators, but don't be like me and try to figure it out on the fly. Just maybe read your instructions and you'll be able to figure out how to use them. But whichever type of calculator you have, learn how to use the logarithm button. It's extremely important. If you're having difficulty, just get some help, learn how to use it, and you'll be able to figure out all of the pHs and pOHs. Most of the time, you're going to see really easy ones you can do in your head, but just in case, you still need to know how to do the ones that have numbers that you can't do in your head. Okay, the next topic, and practice with worksheets, practice with extra homework, you'll be fine with pH. Next topic is salts. Okay, there are some salts that if you put them in water, they make the water acidic. Now, normally if you put an acid in water, it makes the water acidic. If you put a base in water, it makes the water basic. But if you put a salt in water, you're not thinking, okay, what is that salt doing to water? There are 3 different types of salts. There are acidic salts, there are basic salts, and there are neutral salts, okay? So how do we get the 3 different types of salts? Acidic, basic, and neutral salts. Okay, remember how we said that in order to get a salt, you have an acid plus a base will give you a salt and water. Okay, how do you get an acidic salt? So in order to get an acidic salt, this is what you need. You need a strong acid. Remember one of those 7 strong acids, hydrochloric, hydrobromic, hydroiodic, sulfuric, nitric, perchloric, and chloric. Those strong acids and a weak base. So your acid, your strong acid with a weak base, you're going to get an acidic salt. Okay? Now, if on the other hand, you have a weak acid and you have a strong base, guess what's going to happen? The base is going to overpower the acid and you end up with a basic salt. Okay? And then the third scenario that we're going to be exposed to is a strong acid and a strong base. So both the acid and the base are strong. Remember, the strong bases are the group 1A metal hydroxides and the heavy group 2A. So if you have a strong acid and a strong base, they cancel each other out. You end up with a neutral salt. Okay? Now, if you have a weak acid and a weak base, there are lots of different scenarios that can occur. So we're not going to even go there. You have to do some calculations to figure that out. But for these basic things, you should be fine. Okay? So just as a quick example, let's say I had hydrochloric acid and I had sodium hydroxide. This is a strong acid. This is a strong base. Coming together, they're going to form sodium chloride. Strong acid, strong base, sodium chloride. What type of salt will it be? It's going to be a neutral salt. So you throw that into water, it's not going to change the pH of water. Let's try another one. Let's say we have nitric acid and magnesium hydroxide. Remember, magnesium hydroxide is not a heavy group 2A, so it's not considered a strong base. So the salt that we end up getting is going to be magnesium nitrate. Again, remembering nomenclature from previous chapters. Nitrate is -1, magnesium is +2. This is magnesium nitrate. So what type of salt is that? This is strong. Nitric acid is one of the 7 strong acids. Magnesium hydroxide is not a strong base. So you end up getting strong acid, weak base. This is going to be an acidic salt. So this one is acidic. So sometimes what you'll see is that they'll give you the salt and tell you, okay, what type of salt is it? So the only way you can figure out is to see what the original acid and the original base are. And this is the way you can do that. When you have the cation, with the cation, add hydroxides. That'll give you the original base. With the anion, this is the anion, add a hydrogen. This will give you the original acid. Once you've got the original acid and the original base, you look at them. The original acid, this is one of the 7 strong ones. This is not a strong base. Strong acid, weak base gives you an acidic salt. So if you are given a salt and the question is this acidic, basic, or neutral? What do? On the cation, add a hydroxide. On the anion, add a hydrogen. And then look at them and decide, is this a strong acid or a weak acid? Is it a strong base or a weak base? Okay, that's the thing with salts. Now, salts are electrolytes. There's a quick term that, we talk about electrolytes in this lab. Not in this lab, in this lecture. You saw it in a previous lab earlier with the light bulb lighting and all of that. The term electrolyte, this is basically something that will produce ions in solution, and it will conduct electricity. So all strong acids and bases are strong electrolytes. And all soluble salts, remember the solubility guidelines a couple of chapters ago, all soluble salts, all those soluble compounds, remember the ones that were in solution, all soluble salts are also strong electrolytes. So if I tell you, is this a strong electrolyte? Yes, it's going to light that light bulb quite a bit. Why? Because it's a strong acid. Is this a strong electrolyte? Yes. Why? Because it's a strong base. Is this a strong electrolyte? Yes. Why? Because it's a soluble salt, because all group 1A were soluble. Remember that from 2 chapters ago. So that's what I need you guys to know about electrolytes. There's a section in your chapter that deals with equivalents and milliequivalents of electrolytes. We're going to omit that. We're also going to be omitting the Henderson-Hasselbalch equation, and we're omitting titrations this semester. So those are topics that you may see in your homework, but I'm not going to be quizzing you on them. The last key topic I want to cover is buffers. Basically, a buffer is something that prevents dramatic change in pH. Okay, so buffers are usually made up of 2 substances. It's usually a weak acid and its conjugate base. And what is the purpose of a buffer? It prevents large changes in pH. Your blood is buffered. There's lots of things that are buffered so that if by some wild chance too much acid is thrown in, eventually buffers won't work. But for a buffer to work, if you throw in a little bit of acid or a little bit of base, it's going to keep the pH as close to what it's supposed to be as possible. A typical buffer system is carbonic acid, which is a weak acid. Sorry, this is carbonic acid, and its conjugate base, the bicarbonate ion. Okay, that's considered a buffer, a good buffer. Do you think HCl and Cl minus would be a good buffer? Absolutely not. Why? Because in order for it to be a buffer, you need a weak acid and its conjugate base. This is a strong acid. All right. And that's pretty much it. I think I've covered all the key topics that I wanted to. Know what a buffer is, know what electrolytes are, which salts are acidic. Yep, we are done with this chapter. Congratulations. We are all set.